All right, this is section 6.2. We're going to just solve a few more trig functions on this one. What I'm going to do is the starter for this class. I'm actually going to have you guys do this starter in class, but to get credit for your notes, I want you to write the words "Go Bison" right where I write it right here on your notes. And then when you come in tomorrow, I want you to just get your notes out and actually start completing this problem right here to the best of your ability. And it's very similar to the ones we did in class today, so it should not be overly big stretch. And then we'll talk about what it means for all degree solutions at that time. Okay, what I'm going to do is I'm going to move on to the hard ones just to shorten this up a little bit. And I want to solve this equation, all right, between 0 and 2 pi. So what that means is I know that all my answers need to be in radian measures. Okay, and to do this, if I ever need to solve, I need to equal to 0. So that cosine on the bottom, that's a problem, okay? So how do I get rid of it? How do you get rid of a cosine on the bottom? You must multiply everything by cosine. That's a C, by the way. Cosine x. Cosine x. So if I multiply all of these things by cosine of x, I would end up now getting 2 cosine squared x minus cosine x equals 1. I can't have anything in the denominator and solve it. So I multiplied it out. And now I'm going to subtract the 1 over. So I now have 2 cosine squared x minus cosine x minus 1 equals 0. Okay? And now I'm going to have to try factor it. I think I can do this. 2x squared minus x minus 1. I think that will work out just fine. So I'm going to set my 2 sets of parentheses. So 2 cosine x, and it's a 1 and a 1. 1's negative, and I need my adding to be negative. So this is a negative, and that's a positive. Okay, now you just set them both equal to 0 separately. So 2 cosine x plus 1 equals 0. And then the other one will be cosine x minus 1 equals 0. And you just solve. So I'm going to do one at a time. Let's see, subtract a 1 and divide by 2. So cosine x equals negative 1/2. Where is cosine negative 2 and 3? Negative 1, 2, 2. So that's the square root of 3, negative square root of 3. And I want it in radians, so even though this is a 60-degree answer, so I would say it'd be 120 degrees, and what, 60 passes 240. I don't want that because I want my radian measures. So I will end up getting x is, let's see, 120 be 2 pi over 3, and 240 is your 4 pi over 3 answers. Okay? Now, if I have cosine x equals 1, ooh, that's interesting. Where is my x value exactly at 1? X at 1. X at 1. Only here. Okay? Since I include both 0 and 2 pi, I need to write both of them. And that's the only place that is happening. It's only there. So 0 degree, or 0 radians, I guess. And then 2 pi radians. There's no other place on my graph where my x value is exactly 1. So that's how you go about doing a 1. If you have a fraction, you need to get rid of it, multiply every part of it by that trig function, and then it's a matter of solving in that way. Okay? Number 2, cosine double angle. That's not good. You cannot solve one that has a double angle and one that has a single angle. You need to make the double angle go away. So you're going to need to go to your salmon sheet, find sine of a double angle from last chapter, and we need to dump that back in. So 2 sine theta cosine theta is your double angle formula. Plus square roots of 2 cosine theta equals 0. Yikes. Is there anything in common that you guys see? And that's what I do on this one. In this case, if I'm trying to solve, they're not the same. You can't combine them, so look and see if you can factor a different way. What's your greatest common factor? Cosine theta. I'm going to take that out. What's left? 2 sine theta plus square root of 2 equals 0. Nice. I can do this. Okay? Now I have this equal to 0 and then that equal to 0. So where is cosine theta equal to 0? And I'm just going to solve that one right now. If I think about my x value being 0, that's straight up, because that's 0, 1. And then straight down is the other one, 0, negative 1. And I want this in degree measure, so what's my degree measure straight up? 90 degrees. And what's my degree measure straight down? 270 degrees. So that one's easy. I like it when it's 0 or -1 like that. Okay, how about this one? I'm going to do that in blue maybe. So 2 sine theta plus square root of 2 equals 0. Subtract root 2 and then divide by 2. So sine theta equals negative square root of 2 over 2. So sine's negative. Negative. Quadrant 3, quadrant 4. Root 2 over 2, that's similar to 1 over the square root of 2. That's a 45, 45, 90. Okay? So 1 square root of 2, -1. And then this could be -1 square root of 2, but that's a +1. So this is a 45-degree reference angle. And since I want them in degrees, see 45 degrees past 180, 225, and then 45 shy of 360, what, 315. And those are my 4 answers to this one problem. Okay? All of these are answers for this original equation. Okay? So that's kind of neat that we can go through and do that. Alrighty then. We need to go back up. What do we have? Cosine double angle plus 3 sine theta minus 2 equals. Yee boy. So what could I do? I want sine. See this double angle formula? And there's what? Like 3 possible ones that you have on your salmon sheet. But since I have just sine theta, you guys are going to want the double angle formula for cosine that only has sines in it. So you can have it in the same variable so you can solve it. So I'm going to say that this cosine double angle is going to be 1 minus 2 sine squared theta. Okay? Then I'm just going to add the rest. Plus 3 sine theta minus 2 equals 0. That's kind of neat. What else do we have here? I can combine my 1 and my -2. So minus 2 sine squared theta plus 3 sine theta minus 1 equals 0. I do not want that -2 there. That's just a pain. So I'm going to factor out a -1. And that makes it 2 sine squared theta minus 3 sine theta plus 1 equals 0. Now I actually can just divide that -1 out and it just sort of kind of disappears because we're just solving. It's not like we're graphing. So 2 sine theta. I'm going to try factor this. And then a 1 sine theta. I know it's a 1 and a 1. I know they both need to be positive or both negative. So since it's negative, they both need to be negative. So the factoring on this one turns out to be pretty easy. Once you establish that you have to dump in the correct double angle one and then take out this -1, it becomes pretty quick and simple. Now it's just solving. I'm going to jump to it right away. Sine theta equals, I add 1, then divide by 2. Okay? So if I draw this out, positive sine, so 1. Well, what am I doing? It's not 1 and 4. 1 and 2, everybody. Woo. So that's a 30 degree and another 30 degree. But I'm 30 degrees shy of 180. So 30 degrees and 150 degrees would be the answer here. Okay, how about sine theta equaling just a 1? Where's my y value at 1? Only up. This is the only spot where my y value is at 1. So I only get one answer of 90 degrees for that particular one. So there are times when you're on a quadrant line that you could only get 1. Okay, that can happen. All right, but just make the connection that it's going to be on a tangent line. So in this answer, there's 3 possible answers. And the last one. This one's a little more intense. Once again, let's see. We don't have a double angle this time. It's cosine squared. I cannot have a cosine squared or cosine and sine. Which one's the easiest to change? We have a Pythagorean identity with sines and cosines in one. Okay? So when you think about your sine squared plus cosine squared, if I want to solve for just cosine squared, I would go 1 minus sine squared. So 4 times this guy solved for itself over there is 1 minus sine squared x. plus 4 sine x minus 5 equals 0. So that's kind of the process I worked through on that, and now it's just algebra. So you distribute the 4 in, 4 minus 4 sine squared x plus 4 sine x minus 5 equals 0. Just like the previous problem, I'm going to add the 4 and the negative 5 together. So I get minus 4 sine squared x plus 4 sine x minus 1 equals 0. Once again, I don't want the negative up front, so if I factor out a negative 1, and then once again, I magically can just sort of kind of divide the negative 1 out and it goes away because you're solving once again, not graphing. Same drill, let's factor this. So, okay. 4 sine squared. It could either be 4 sine and 1 sine or a 2 sine x and a 2 sine x. I'm going to go 2 and 2, and then since I see a 1 and a 1, it's going to work out really well because it's going to be minus and a minus. Okay? What do you guys notice about these two, though? They're going to end up being exactly the same. So if you solve sine x equals 1/2, you're going to go sine x equals 1/2. Do you have to solve them both? I hope you all say no, because they're exactly the same. If you have the same thing, solve it once. You're going to get repetitive answers. You're only going to list them one time. Okay? So where would you go sine inverse of 1/2? I think we've already done this. So this is a 30. And this is going to be a 30. So x will equal 30 and 150 degrees. If you write that as your answer, do you get full credit? I hope you're all looking at your interval that I asked for. It's in radians. So your actual best answer would be pi over 6 and then 5 pi over 6. Okay? So I just showed you a little bit more difficult problems in which you have to do some substitution with double angles and Pythagorean identities, but the process of solving is still exactly the same. Look for both answers if you can get them, and we will definitely work on whiteboards and in class on these tomorrow. So I hope you all have a great day.